Good morning, grade sixes. Welcome to STEM Digital Lockdown School. Awesome to have you back. Good morning, Kiara. Good morning, Boncle. Good morning, Michael, the YZ. What is in store for today? Well, why don't we have a look? Remember I said to you, we're going to do a bit about mixtures. For those of you that haven't been with us before, my name is Sheena Cooney, and I'll be your teacher during this time. And then you can see at the bottom my email address for any homework that you want to share with me, or any feedback or any questions. You're more than welcome to email me. I will do my best to help you. So I did get homework, by the way. Nduvo, well done. Look how neatly that's done. Very nicely done. I did receive your email, and I am very, very happy to say that it's actually quite neat. Your handwriting is very neat. So well done. They all look correct to me, and I'm very proud of you. Thank you so much for taking the time and the effort to complete it and to send it to me. I really, really appreciate it. So good job. Lots of pats on the back for you. Well done. Now, today we are going to mostly talk about mixtures. Okay, so we need to try and not digress off the subject. I know that we do tend to do that, but we're going to talk about making mixtures, two solids, a solid and a liquid, two liquids, and look at examples of materials that we like salt and sand and sugar and tea leaves. And then we're going to, by the end of the lesson, hopefully be able to explain the different kind of mixtures. So if you couldn't get it, it's absolutely fine. Don't worry. If you are able to get it even next week or after this lesson, regardless, you can still send me your homework. It's really not a problem. Okay, I don't mind. It's always good to practice and go over the things that we have learned before. So our new words today, where do I get the homework? Oh, the homework sheets, Talia, they are on the African Teen Geek website. All right. So you can even email me just so that I have your email address and I can send you the link. We can do that as well. It's not a problem. So, but everything is on African Teen Geek. And then you go there and they've got all the subjects, they've got the PowerPoints, the homeworks, whatever. If there are some missing, it's because they're still busy updating. Okay. So our new words today are mixture, separate. Look how you spell separate. A lot of times we tend to spell it with S-P-E. Okay, we mustn't do that. It's A, separate. Separate. Okay. And then we have variety. So these are our new words. Well, they new words for this lesson. We're going to use them quite a bit today. So what do we know about mixtures? How can mixtures be separated into different materials? When is a mixture also a solution? What is a mixture? So let's start with the first question. What is a mixture? Then we're going to focus on when is a mixture a solution, and then we're going to focus on how can mixtures be separated. All right. Now, this question will come up on the slides that we do it in, so you don't really need to write it down now, or if you started writing it down, it should still be on the next slide. Okay, so what is a mixture? Well, a mixture is when you take two or more different materials and you mix them together. Sounds simple enough, doesn't it? Okay, now in some mixtures, we can actually clearly see the materials that we are mixing, and in some we can't. But in the image that I've shown you, can you see what we've mixed there? So we've got a nice mixture there. Nice mixture there of yummy, yummy peanuts and raisins. Now they are mixed. They are mixed. Can you still see the peanuts and the raisins, even though they are mixed? Yes, you can. Yes, you can. Now, do you think it would be possible to actually separate the peanuts from the raisins? Okay, and how it's okay, Kiara, you can take notes. You can take notes. Rather take notes of the words on the slide instead of what I'm saying, because you can always rewatch the video. It will be online, okay? So I don't mind staying on the slide while you write it. So yes, you can actually separate them. You just pick them. Yes, well done, Zaina. It is hand sorting. That's exactly what we're going to get to. So you actually literally take your hand and you sort them with your teeny weeny fingers, and you separate your raisins in a pile and you separate your peanuts in a pile. Okay. Now, often some people, instead of just buying peanuts and just buying raisins, they'll buy the mixed bag and then they'll pick out the raisins because they don't like them. So we do have, do you guys like peanuts and raisins? I love peanuts and raisins. I think, would it be easier to pick out the raisins or would it be easier to pick out the peanuts? What do you think? Which one would be easier to pick out? The raisins, exactly right. The raisins, they are easier because they're squishy and they're soft and they're sticky. So you just stick your fingers in, they literally stick to your finger and you can pull them out. And can you actually think of other mixtures in which we can mix materials and they're still visible? Yeah, if you're allergic to peanuts, please stay away from them. It's not good to eat them if you are. So other than this example I've given you, can you think of other mixtures where you can mix two things, but you still see them? So you mix two materials and you can still see both of them. Okay, well, ice cream, you can't really, because it's you can't really identify two different things in it. Maybe two colors, but maybe not two mixtures so much. Why are we talking about volcanoes? Michael, no. We talk. I know it's a mixture, but you're taking me off track, right? Okay, soup and samp. Actually, that's true. You do see the samp and the soup. Morning. Oh, different colored jelly beans. Oh, I got some nice suggestions here. Okay, so let's see what Miss Keeney found. It's okay, Michael. I just actually look forward to you chirping in every now and then because you seem to have a love for science. There we go. There's the question that was supposed to be flying in the beginning, rather late than never. How are you doing, Kiara, with the writing down? Can I go to the next screen, the next slide? Okay, no, don't stress, sweetie. I don't mind waiting for you, and I know the group doesn't mind waiting for you. What was that again, Michael, that you said about volcanoes? I'm quite interested in reading it. I don't know if everybody else can see the chat. It says, you said, when a volcano erupts and lava flows down the volcano and you put water in it, it turns into obsidian. So it's a mixture of fire and water. That's very interesting, eh? That is very interesting. Good. I'm glad to see there's still more people writing notes. That's excellent. Well done. Good job. So if I go quiet, don't worry, I am still here. That's true, you can mix red and blue pens, actually. We're going to do a little table of different mixtures so that you'll have a nice variety of examples. I used to have all my pens mixed together, and then I managed to get some tub holders. And now all my black pens are in one, all my red pens are in one, and all my blue pens are in one. I think I need another one for all my Sharpies. They also need their own holder, I think. Oh, there we go. Different fruits in a fruit salad. Very good. That's a good one. Well done, Duval. Welcome. I hope you saw that I hope you don't mind that I shared your homework that you did for me. It's really, really good. Thank you so much. Very, very pleased. So here we go. This is what I wanted to show you. We have our different colored jelly beans, as was suggested. Okay, you can see the colors very clearly. Also, you suggested fruits and a fruit salad, and there you go. There you can see the different pieces of fruit. You are right, a mix of ducks and swans together on a lake, a mix of red and orange and yellow and green peppers, a mix of pink, yellow and white flowers in a field. And then you also get different shells mixed up on the beach. So these are mixtures that you can really see clearly. All right. And the thing is, the mixtures that we are going to learn about, a lot of them are mixed so thoroughly that it looks like one material has actually disappeared into the other. And those kind of mixtures are called solutions. Okay. So that is definitely what we're going to be looking at next. All right. Well, yes, I suppose ice cream can be a mix. It does depend what you ordered, though. I was just thinking of plain ice cream. Okay. Very good. Someone's on the ball. A mixture is a solution with insoluble and soluble substances. Okay, so let's start off with a simple example. Now, I don't expect you to actually do this, but you can use your imagination. All right. In the picture, I have rice on the left and I have barley on the right. In the jars, I have rice and I have lentils and I have barley. Okay. Now, these kind of materials, when you mix them together, what do you think it's going to look like? Barley is, how do you explain barley? You know, you can even get barley coffee. It's very, very, very healthy for you. It's like similar to like having a wheat, or someone asked me to go back, so I'm going to go back quick. It's similar to, you know, like growing wheat and different things like that. Okay, I'm just going back so that somebody can, so that those who are busy writing can catch up. All right, so very good, Kiara. It's like oats. Barley's like oats. It's a grain, a cereal grain. Okay, so it's very, very healthy for you. Very, very healthy. Do you know that you get barley coffee? I once had barley coffee. It was so actually surprisingly good. Okay, so for those of you still writing this down, I'm going to wait here a little while. Okay. There we Go. All right. So can you still, if you had to imagine mixing these two ingredients together, can you still see the individual rice and barley grains? Do you think you can still see them? So yes, you can still see them. Okay, they are both grains as well, which puts them in the same category as each other. So when you mix them, you can actually see both of them. Yes, you can screenshot it, not a problem. Right, so how are we going to separate a pile of rice grains and a pile of barley grains? How would you separate them? So if we've mixed them together, how are we going to separate them? Very good. You very possibly need to hand sort them. Okay, because you can't sieve them because they're both approximately the similar sizes because they are grains. So you're going to have to sit there quite a long time and sort them out. When you mix them together, did the barley and the rice grains change, or do they still look the same as before they were mixed? So will they still look the same when you mix them? Very good. You're absolutely right. They don't change. They look exactly the same. What did you share with us? Okay. Oh, was it a mistake? Okay, I'll delete it. Right. Let's move on. I'm getting a bit distracted here. You guys are very good at distracting me. Okay. Right. So now let's look at another one. Okay. What if we were to mix rice and sugar? So if you were to go and mix rice and sugar, now it doesn't have to be exactly 10 scoops. You can just mix a small amount just to see and be able to visually imagine the difference. Okay. So you mix them together. All right. Now, can you still see the rice and the sugar grains? Okay, so some say yes, some say no. I'm sure I did find an image for you. Okay, so now if I had to mix them together, you would definitely see the rice grains a lot better than you would see the sugar grains, okay? But as you say, you might still notice it, okay? Because they're both dry ingredients. But now look at their size. Look at their sizes. If you had to separate this mixture, how would you do that? Because the sugar grains or the sugar crystals are a lot smaller than the rice. Very good. Probably a sieve would, because the sugar would go through the sieve and the rice would possibly sit up on top of the sieve. Is there a quick way using the sieve? How would you use the sieve when you're trying to separate them? So you've got to be, with science, you've got to be able to explain, even if you know how to do it, even if it's easy and, you know, even if you don't think you need to in science explain how you do something. So yes, you told me you can separate the two. You also told me correctly that you can use a sieve. Now you need to tell me how. Pretend that I'm really don't understand. So explain to me as if I'm someone who really is blind and can't see what you're doing. So explain it to me that way. Okay, so I hit on the side so the sugar can come out. With the side of what? Okay, so that's good. That's right. Now remember, if you're answering a question like this in class or on a paper, remember to start off by saying to separate a mixture of rice and sugar, we pour the mixture into a sieve. We tap the sieve on the side so that the sugar grains or crystals can fall through the sieve and the rice remains on top. So you need to be able to explain each step. Even if you know and you understand it, you've got to pretend that the teacher or whoever's marking it cannot imagine that you know. They have to be able to visualize what you're doing. Okay, there we go. So just bear that in mind when you answer questions like this. All right. Okay, let's go to the next one. Can I go to the next one? Okay. You're busy writing. Okay. You can, yes, actually, you can call it sifting. That's actually a good word to use. No, it's okay. Don't worry if you forget words. It's just, that's what I'm here for. I'm here to help you. I'm here to remind you. I'm here to assist you. So, yes, you can, it's a very good word to use, sifting. You sift the mixture through a sieve. That's very good. The way to say it. Okay, now I know some are still writing, so I am going to give them a minute to write this down. You don't have to call it a sieving thing. You can just say sieve. It's a sieve. You sift through the sieve. So it's going to be like S-I-F-T, sift through a sieve. There we go. You can actually use alliteration in that one. To sift sugar through a sieve to separate the mixture. You can also, yes, you can, a strainer would be, I'm trying to think, a strainer's got bigger holes. You know, like when you strain vegetables, you use a strainer. It's got like bigger gaps than a sieve. A sieve has a lot more finer gaps. Okay, now a sieve you definitely need to use for baking, absolutely. Straining we usually use when we need to strain our veggies after cooking them or if we need to wash veggies. You didn't miss anything, Kiara. I'm still on the same page. Okay, so yeah, it's always good to have both of those, a strainer and a sieve. You even get a little sieve. Like if you look at those tiny sieves, you get those little ones. Then you get a tea strainer. A tea strainer for your tea bags or your tea has bigger holes than the little tea sieve, which has smaller holes. I actually take a photo. I've got both. I'll take a photo and maybe put it up tomorrow or next week, okay? I do, because I do have two of them, then you can see the difference between the two as well. Okay, did the sugar and rice grains change in any way when you mix them, or do they look the same once they were mixed as before they were mixed? Okay, so because there was no liquid added to dissolve the sugar, then it won't change. They're both dry mixtures. So you are right, they did not change. You maybe one grain is bigger than the other, but they both remain the same. Okay, they don't change. So well done with that. Good job. Kiara, do you need to ask a question? Or are you good? Okay. All right. Any other questions before we go to the next slide? Are we good? Well, sugar, we're actually getting to that. Sugar will stay the same because you're not dissolving it. You're not putting liquid into it. Sugar only changes when you use heat. Okay. I have added links on the videos that we do and the lessons we do. Okay, let's look at it this way. I'm using sugar again, okay? But now I'm using sand. All right. So if I stir the sugar and the sand until they are mixed, what do you think will happen? Okay, so I'm reading your answers here. Sorry, Leah, I'll try and remember. Okay, so some say you'll only see the sugar and some say you'll only see the sand. Now, this is something you could possibly actually try at home because I'm sure we all have a bit of access to sand and to sugar. Okay. So someone asked about processed foods. Processed food is a mixture, but the reason why it's called process is because it goes through a mechanical change or it goes through a chemical change. Okay, so I would consider it a mixture. All right. Okay, so let's see how we're going to solve this one. So look at the first one before I've mixed them. And look at the second one where I've mixed them. Can you see the individual sand and sugar grains in that mix? Look at the spoon. Okay, so you can see them, but which one do you see a lot more clearer? Yes, you can see the sand. Yes, you can print the homework when you access it, absolutely. You can definitely see the sand more clearly than the sugar. Okay, because sand grains are bigger than sugar grains. Now, how would we separate sand and sugar? So how would we, with sifting? Sifting, okay. All right, do you think you can do it with a sieve then? The reason why I pause for a while is because I'm trying to read everybody's answers and make sure everybody gets a turn. All right, so some say sieving, some say sifting, some say filtering. Possibly the easiest way, I'm trying to see if somebody said filtering, So I'm just trying to see, how would you do that if you use a process of, how do you suggest we do that if we use a process of filtering? Well, there is actually a much easier way. Are you ready? If you dissolve it, if you mix, add water to it, right? And you wash the sand with water, then what happens is the sugar dissolves, doesn't it? And then what you do is you wash the sand off, you wash it off, and then the water that's washed off, you heat, okay, so that it evaporates from the sugar. So you're heating up your leftover water from washing the sand and the sugar, all right? And then once the water is evaporated from the sugar, then you have your sand on the one side, and then you have your sugar left from the evaporation process. Does that make sense? Okay, so I'm reading your answer about the pan for filtering. Okay, so that is also part of the process. Okay, so this is how you would do it. So listen carefully. You add water covering the sand and the sugar. Okay, so you're adding water to just cover the sand and the sugar. You stir in the mixture until you can see that the sugar is dissolved. All right. Then you strain it through what they call it is a filtering container, a metal container that you use to filter with to remove all the sand. And you put this metal container on a stove burner on a low heat until the water evaporates. Then the dry sugar will be left in the metal container. Okay, so I haven't typed this up, but that is not a problem. I'm sure we can do that. So you are using the process of dissolving, you're using the process of filtering, you're using the process of evaporation. So you are actually, in effect, using quite a few stages and steps to separate the two. They're not that easy to separate. Okay, it will take a bit of time. There you go. Well done. Well done, Leah. Nice explanation. Very good. Okay, so in the previous activity, we mixed solid materials. Remember, they were different size grains, okay? And when the grains are large enough, you can separate by hands. However, some grains are different sizes and you can't separate them by hand, so you have to separate by sieving. So there's hand sorting and there's sieving, okay? Now, let's look at our next, now we're going to go on to the liquids, okay? If I put sand in a mixing tub and water, okay, so I'm going to put the sand, if you look at my example that I've given you over there, if you put the sand and the same mass of water, all right, and then you mix them, can you still see the individual sand grains when you mix them? So can you still see the sand grains when you mix them? Okay, grade sixes, make sure you keep your videos off, please. All right, so yes, you can actually see the sand grains when you mix them. Now, it is mud if it is not settled, if you know what I'm saying. Because if you look at when you mix them, do you notice because the sand is heavier and more condensed, it sinks to the bottom. Do you see that? It sinks to the bottom. So although they are mixed, the sand will eventually settle to the bottom. So it's not like when you mix cool drink. When you mix cool drink, you can't see the water from the concentrate, but with sand you can. Right. Now, can you separate that mixture once it's mixed? Exactly. Sand doesn't dissolve. You're right. Definitely the water goes brown. Not all of them, no. Some of them are probably from there, but not all of them. I needed to find pictures that were clearer. You can separate them. Okay, so, but how? How would you pick them? The sand grains one by one? Would you use a sieve? How would you separate them? Okay, so I've got a suggestion there using a filter. And another suggestion for using a sieve. Okay, filter, quite a few filters. That is absolutely correct. You will need to filter it. When you add sand to water, it kind of hangs in the water and it forms a layer at the bottom of the container because, as you said to me, sand does not dissolve. Okay, it's an insoluble. So it's easy to filter them to separate them by filtering. Okay, you can also, for example, with salt and sugar, use the method of evaporation. You just can't with sand. So with sand, you'll need to use a filter. Okay. So yes, I think you all understand that by what I can see. Filtering is much easier, and you all understand that sand is insoluble, it cannot dissolve, and it'll sink to the bottom. Okay, so have we got this? Yes? Okay. The countdown is making me nervous, Michael. Oh, my word. Okay, would it be possible to separate them using a paper towel? Someone mentioned that earlier. Who was it? Duvo. Would you use a paper towel? And would it work? What would you do? How would it work? I honestly I haven't actually tried that. So have you tried it? Okay. And what happened when you used a paper towel? Remember, it's a paper towel, not a cloth towel. So what happened when you used the paper towel? Okay. All right. So the paper towel would possibly absorb the water. Right. I do think it does. It would work, but I think that just not too much water because you don't want the paper towel to just become so soft that it disintegrates. Okay. So it does depend on the volume of water you're going to pour, but it can work. It can work. And if you use a cloth, you should actually try it. And you can even video it and send it to me or put it on our Flipgrid and share it with me. And then I can watch the video and then I can see how it worked for you. Just remember your volume must be the same of your sand and your mass must be the same of your sand and your water. Okay, we're getting to the sponges. We're going to do sponges when we do wetlands. Okay, so now, why don't you try that at home? Well, I did check the Flipgrid and I think someone did use it and they said it was working because I did check homework there. So I'll go and check it again, but just try it again and see. Right, very good, Leah. It does depend on how thick the paper towel is and how much, obviously, you're putting on it. What about a normal towel? What about a normal towel? Would you be able to do that? So these are two experiments that you can actually try, okay, at home, and you can video yourself. Now, I'm going to show you now how to send the video, okay? I'm going to move down quickly because we can carry this on tomorrow. Oh, I don't have my Flipgrid on here. That's not cool. Okay, guys, what I'm going to do is I'm going to open up my Flipgrid page quickly just to show you. And let's see. Oh, I don't have a Flipgrid for grade 6. You're absolutely right. I don't have a Flipgrid for you. I'm going to set up one today, okay? So today I'm going to set up a Flipgrid for grade 6s. Any suggestions for Flipcode? Yes, you can do an experiment with the towel that you bath from. Okay. So any suggestions for flip codes that we can call it for grade 6s? So grade 6 geeks. Okay, cool. Well, if you have any ideas, until that's set up, what you can do is I will explain to you, Leah, what a Flipgrid is tomorrow. I'm going to put on a page on our PowerPoint with the exact steps on how to use the Flipgrid. I'll provide you step by step, and I will do a flip code. Okay. Okay, so I'm reading all your ideas, and we'll see which one we can come up with. All right. But for now, if you're doing one and you want to send it to me, you can send it to my email address. Okay. If you want to get the homework, it's on the African Teen Geek website. Okay, the African Teen Geek website. So you can go on there as well. If you're not sure, you can just email me and I'll send you the link. All right. So, I like that one, grade 6 geeks. That also looks serious 6. Nice. Awesome. Okay, guys, so I'm going to go and work on that now. I hope you have an absolutely awesome afternoon. Go do some experiments for me, video it for me, or take pictures. Either way, it'll be awesome. I can't wait to see them. And I will chat to you tomorrow. Okay, so I'll see you same time, same place tomorrow. Have an awesome day. Love you guys. Thanks for joining me today. Bye-bye. See you later.